Okay, so let's do a quick recap of confidence intervals. Okay, now a confidence interval is an interval that we can say with some degree of confidence right, that it contains the population parameter of interest. Right? Okay. Now that could be the mean, that could be the population proportion. Right? Those are the two that we have looked at. Okay. So let's talk about the confidence intervals for the population mean first. Okay. Now, when we talk about confidence intervals for the population mean, we run into two cases, right? The first case is when we know the population standard deviation, sigma x, right? And then the second case is when we don't know the population standard deviation. Okay. Now, if we know the population standard deviation, to construct the confidence interval, we're going to use the formula x bar plus minus z sub alpha over 2 times sigma x divided by the square root of n. Okay, where x bar here is the sample mean. Right? Obviously, sigma x is the population standard deviation. N here is the sample size. Okay, and z sub alpha over 2 is the z value. Such that the area to the right of it right, is alpha over 2. Okay, in other words, if you draw the standard normal distribution, okay, and if this is z sub alpha over 2, then this shaded area is equal to alpha over 2. Okay, now if we don't know the population standard deviation sigma, then the formula we're going to use is x bar plus minus t sub alpha over 2 with n minus 1 degrees of freedom times sx divided by the square root of n, right? Okay. Where x bar is also the sample mean. Okay. Sx is the sample standard deviation, and then n is the sample size. Okay. Now t sub alpha over 2 with n minus 1 degrees of freedom is the t value such that the area to its right is alpha over 2 when the degrees of freedom df is equal to n minus 1. Okay. Again, in other words, if you were to draw the t distribution, right? Remember the t distribution is also a normal distribution, right? So if this is the t distribution with n minus 1 degrees of freedom, then if this is your t sub alpha over 2, the area to the right of it, the shaded area here, is alpha over 2. Okay. So then we also talked about how to construct confidence intervals for the population proportion, right? Now when it comes to the population proportion, there's only one formula that we use, right? Which is p bar plus minus z sub alpha over 2 times the square root of p bar times 1 minus p bar divided by the square root of n. Okay. Where p bar in this case is the sample proportion, okay, and then z sub alpha over 2 and n are defined similarly to the two above, right? Okay. Then we talked about how to determine sample size, right? So when we determine the sample size for the mean, we use the following formula. N equals z sub alpha over 2 square times sigma x square divided by e square, right? Where e is the desired margin of error, okay? When it comes to the proportion, the formula for the sample size is n equals z sub alpha over 2 all square, right, times p star times 1 minus p star divided by e square. Okay, where e again is the desired margin of error and p star is the an estimate of the population proportion. Right? So three ways we can obtain an estimate for the population proportion. In other words, three ways to determine what p star is. Okay, the first way is to do a pilot study. The second way is to use a comparable study. And then the third way is if neither of those methods works, then we use a value of 0.5 for p star. Okay. And for this kind of problem, when you determine the sample size, if you get a decimal number, you always round up to the next whole number, right? Okay. If n happens to be a decimal number. Okay. So now, I think it may be helpful to just kind of do a quick summary of when to use the z table and when to use the t table. Okay. 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 So let's say we have the z table here on the left hand side, and then here we have the instances where we use the t table. Okay. So let's go back to our formula, right? When we know the population, when we construct a confidence interval for the mean, and we know the population standard deviation sigma, then the formula tells us to use the z value, right? So that is one case. So let's put it there. Okay. All right. So let's see where else we use the z table. If you look down here, when we construct the confidence interval for the population proportion, we also use the z sub alpha over 2, right? So CI for population proportion. Okay. And then if you look at the formulas for the sample size, right? Both formulas call for z sub alpha over 2. So we use the z when we want to determine sample size, right? Okay, so sample size determination. Now the only instance when we need to use the t value is when we want to construct the confidence interval for the population mean when the population standard deviation is unknown, right? This is the only formula where we use t sub alpha over 2, okay? So I hope that this table will help you determine when to use the Z table and when to use the T table. Okay. Now the final thing I want to review is to look at how we read the table. Okay. So suppose this is my Z table, right? And suppose I'm looking at the 95% confidence interval. If I'm looking at the 95% confidence interval, I'm not going to walk you through the step again, but at this point, you should know that alpha is 0.05, and so alpha over 2 is 0.025. Okay, so the idea is we want to find Z sub alpha over 2 to use in our formula, right? So if you draw the distribution, that means if we want to find the value Z sub alpha over 2 such that the shaded area here is 0.025. Okay, now remember the interior of the Z table gives us probabilities, right? And it specifically it gives us probabilities to the left of a given Z value. So in order to use a table, we need to figure out the area of the unshaded part. Okay, and we do that by taking 1 minus the area of the shaded part, which in this case gives you 0.975. Okay, so the idea is you want to go into the table, look for 0.975, and then trace it out horizontally and vertically to get the Z value. Right? So if you look in the table, 0.975 is right here. If you trace it out horizontally, you get 1.9. If you trace it out vertically, you get 0.06. So this Z value is 1.96. Okay? Okay. So I hope this makes sense. Let's look at another example. Right? Suppose we want to do the 80% confidence interval. Okay, then alpha is going to be 0.2, alpha over 2 is 0.1, right? So you draw the Z distribution, then we want to look for Z sub alpha over 2, right? In other words, we want to look for the Z value such that the shaded area here is 0.1. Because the shaded area is 0.1, that means that the non-shaded area is 0.9, right? So you would want to go into the interior of the table, look for 0.9 or the next closest thing to 0.9, and then trace out the Z value. Okay, so if you look in this table, 0.9 is not on here, but the next closest thing to it is 0.8997, right? So if you trace it out horizontally, you get 1.2. If you trace it out vertically, you get 0.08. And so in this case, Z sub alpha over 2 is going to be 1.28. Okay? So that's our Z table. Okay? So now let's go ahead and look at the T table. Now remember that the T table T distributions are distinguished by the so-called degrees of freedom. So what we have here in the first column are different degrees of freedom, right? So 1, 2, 3, 4, 5, and so on and so forth. The first row here, right, gives the area under the curve to a the area to the right of a t value. Okay, and the interior of this table we make a note, interior of the table gives t values. Okay, so see how this table is different from the z table, right? For the z table, the interior of the table is probabilities. In the t table here, the interior of the table gives you different t values. Okay, so now suppose, let's do an example. Suppose we want to look at the 95% confidence interval. So alpha over 2 is 0.025, and let's say the degrees of freedom is 27. Okay, so what we want to do is we want to go to row 27, look under column 0.025, right? Because remember, the first row gives the area to the right, right? So we want to look for alpha over 2. We want to look for 0.025. Okay, so we want to look at this column. And so that gives us a t value of 2.052. Okay. Now suppose we're looking at the same confidence level, right? So 95% confidence interval, but the degrees of freedom is 5. Then our t sub 0.025 with 5 degrees of freedom is this number right here, right? So 2.571. Okay, so see how these using the same confidence level, if you have different degrees of freedom, you're gonna get different values for your t. Okay, so I hope this helps. Now something about the t table that I wanna mention as well is that for the t table, if we have a degrees of freedom of greater than 200, then we use the infinity row.